So these problems are problems from um, the theorems, Extreme Value Theorem, Intermediate Value Theorem, and I thought I'd work through a few of them just to make sure that we are clear on how to apply those in some situations. So I'm going to do four multiple choice, and then I'm going to do two free responses. So let's take a look at this problem. We're given the values for a differentiable function on the interval from 0 to 10. And then we're asked to decide which of these statements are true. So let's take a look. It says on the interval from 2 to 5, there's guaranteed to be a value such that the derivative equals 0. Now, friends, that is asking us about Rolle's theorem. Rolle's theorem says you've got to be continuous, you've got to be differentiable, and the y values have to be equal to each other at the endpoints. So looking at 2, and 5, I see those y values are equal to each other. This is a guarantee. This works for Rolle's theorem. Rolle's theorem guarantees us there's a place on that interval where the derivative equals 0. All right, now on the interval from 3 to 6, there exists a value such that h of c equals -9. This is playing on intermediate value theorem. So let's look at 3, 3, 2, 6, -5. All right, so here's what that's saying, friends. I've got a point at 3, 2. I've got a point at 6, -5. All I know is this function is differentiable, therefore it's continuous, and it wants to know if I'm going to get a y value somewhere in there that goes down here at -9. I'm not guaranteed that. I'm guaranteed every value between the 2 points I have, but I'm not guaranteed a y value outside of that. So number 2 is not guaranteed. And then number 3 says on the interval from 0 to 3, we can we say that the second derivative is positive? That would need to mean that we would need to be able to guarantee that the first derivative is increasing the entire time. I can't guarantee that based on all of the information I have here, and that's why only number 1 can be my answer choice. Okay, let's switch over then. We'll look at another multiple choice question. Which is number 3 here, but it may look a little bit different, maybe like a second one for you. It says to let the function be square root of x if the rate of change, that's code for derivative, the rate of change of f at x equals c, so rate of change of f, that's derivative, it's the derivative at c, is means equals, twice means 2 times, its rate of change at 1, that's f prime of 1, then it wants to know what c is. So let's find the derivative. That would be, think of this as x to the 1/2. So that would be 1/2 x to the -1/2, or 1/2 square root of x. Now, if we want that at c, then I've got to plug in a c for x. And then 2 times, now I plug in a 1, which will give me 1/2. That's 1/2 square root of c equals 1. Now you can cross multiply, divide by 2, and then square both sides. That's how we get that c is 1/4. Okay, so far so good. Hopefully that's making sense to you. Let's look at another one. And I'm sorry that I'm skipping around. I'm only choosing points that I'm sorry, I'm only choosing questions that I really, really want to look at here. So number 5 is just a really good calculator question. So I'm going to flip our format so that you can see my Desmos graphing calculator. There we are. So you can see here below my video, that is still a problem we're working. And let me zoom in just a hair so you can see that. We are looking for the maximum value of x squared sine of x on the interval from 1 to pi. So let me put that function in. Y equals x squared. If you haven't used Desmos before, it's shift 6 to get in the exponent, and then the right arrow to get out of the exponent. And then when you do your sine function, you must put x in parentheses. Desmos will do all the calculator graphing for you. Remember, friends, we're going from 1 to pi, and we're looking for that maximum value. Now, when it asks you for the maximum value, it's asking you for the y value. And so in this case, that would be the 3.945. If you're doing this on the 83 or the 84, remember you can use the second trace menu and do the maximum feature, which I believe is option 4. But you can use that. So no worries if you're still using the 83 or 84, you can do the same function. Okay, I'm going to switch back our view so that you can see our questions again. And we're going to work the very next one. It's for t is greater than 0 hours. H is differentiable. It's a function of t that gives the temperature in degrees at an Arctic weather station. And which of the following is the best interpretation of H prime of 24? So remember, H prime, H is the temperature. So the H prime has to be a rate of change of that temperature. And so that is why we get that it can't be C, it can't be D, and it can't be E. Because it's not average, right? It's not the algebra way of finding the rate of change. This is the calculus way. This is we get that rate of change at the very moment that t is 24. And that is why we must choose B here. It's the change in temperature exactly at the 24th hour of this time interval. Okay, so we've done a few multiple choice. Let's look at a few free response, and I'm only going to do a few of them here. For this one, we are being given F of T represents the temperature outside of a house during a 24-hour time period. F is measured in Fahrenheit and T is measured in hours. Notice that T equals 0 corresponds with 12 a.m. or midnight. So we're being asked for what is the value of F prime of 10? So first, let's find F prime of T. Okay, so the derivative of 80 is 0. The derivative of negative 10 cosine would be positive 10 sine of pi t over 12. And then we've got to do chain rules. So we're multiplying by the derivative of pi t over 12, which would be pi over 12. And now we want to plug in 10. So I'm going to go back to my Desmos graphing calculator. I'm going to clear out our last function. And I'm going to type in this function, but I'm going to put a 10 in place of t. So I've got 10 sine of, and then open your parentheses, pi, you can do pi, times 10, divide by 12. Now, friends, it's okay that the pi did not get multiplied by the 10 on the top. It's going to mean the same thing. If you want to make sure the pi gets on the top with the 10, you have to use an extra set of parentheses. Now, I right arrow to get out of the denominator, and then I close my parentheses. Now I'm going to do times another parentheses. Let's do pi divided by 12, close the parentheses, and there we go, friends. I get 1.309. By the way, if you're using the 83 or 84, you can do the same thing. Just make sure you're in radian mode. Very, very important. Now, this problem, I'm going to switch back our view so that we can look at this closely. We wanted the correct units, okay? So F of T is measured in Fahrenheit, and this little t is measured in hours. So this is degrees Fahrenheit per hour. So, what does this mean? We want to interpret this in the context of the problem. This means the temperature is changing at a rate of 1.309 degrees Fahrenheit per hour when T equals 10 hours. So very important that you have all of those parts in there. You've got the units labeled, you've got specifically when this rate of change is happening. So very, very important. Okay, now we're going to stay with this same function, but I'm going to change the question. So let's take a look at question C here. Is the temperature increasing or decreasing at 9 p.m.? Okay. Now remember, we were told T equals 0 represents 12 a.m. So 9 p.m. would have to be T equals, so 12 hours would get us to noon, and then we need 9 more hours would be 21. So I need to know, is the derivative when T is 21 positive or negative? Now, friends, remember, we just did in part A. We found the derivative when T was 10. So I'm going to switch back to that Desmos calculator. Instead of 10, I'm going to put in 21. So let me type that in. And I get a negative 1.851. Remember, with AP, 3 decimal places is required. Okay, I'm going to switch back then. So is my temperature increasing or decreasing? The temperature is decreasing at 9 p.m. because f prime of 21 is negative. Make sure you have all of those phrases there in that sentence. It's going to be very, very important to making sure that you get credit for those on your AP exam. I hope that helps with our problems with the extreme value, intermediate value theorem, and Rolle's theorem. If you have questions, feel free to leave them in the comments below. Bye for now.